Okay, next insertion method we are going to see in the doubly linked list is inserting new node at the end. Okay, so here we are going to see about inserting the new node at the end of the doubly linked list. So for example, this is the linked list, doubly linked list we have taken, and here we are going to insert. Okay, so here what we have to do is we have to check one condition. So the condition we are going to check is while PTR tends to next is not equal to null. We have to check this condition. Why we are checking this condition is we have to find the last node, right? So in the last node, in the next part it is null. So if it is null means this is the last node. So we have to find this particular node and we have to do the insertion. Okay, we have to do the insertion, and what will happen here in this part, the new node. So this is the new node, right? So this new node address, okay, so this new node address is saved, and here this last node address is saved here, and here what will happen, it will be the null. Okay, so this is the procedure. So we will see in the code. So this is the code. Okay, so here we are using two pointers. One is char ptr and next one is a char new node. So these are the two pointer variable we are using, and here these three steps are common. So we are declaring one integer variable, then by using printf statement we are printing enter the data, then by using scanf statement we are getting the value from the user. So for example, consider the num value. Consider the num value we have taken here is num is equal to 6. Okay, we have taken the num value is equal to 6 here. Okay, so we will check the insertion here. So first, the new node, we are allocating the memory space for the new node by using the malloc function. Then what we are doing, we are storing the data, that is new node tends to data is equal to num. So I am writing here, so there is no space, so I am writing here. So with the value 60, we have assigned the value. The next PTR is equal to start. So this is the PTR node. This is the start node. The first node is a start node. So we are assigned PTR is equal to start. So this is PTR node. Then we are checking the condition, that is PTR tends to next is not equal to null. We are checking the condition. Already I said we have to check this condition to find the last node. So we are checking this condition. If this condition is true means this statement will be executed. That is PTR is equal to PTR tends to next. This statement is executed. Okay, PTR is equal to PTR tends to next. So we will do it. So we are checking PTR tends to next. So next means this part. It is null. So it is not null. Not null means what you have to do? PTR is equal to PTR tends to next. So we have to move to the next node. Okay. Then we are checking. Again we are checking PTR tends to next is null. It is not null. So the next node. This is the PTR. Then we are checking it is not equal to null. Yes, it is not equal to null. Then again we are checking PTR tends to next is not equal to null. Yes, it is not equal to null. Then we are checking PTR tends to next is not equal to null. Here it is equal to null. The condition is false. So what happened? PTR tends to next is new node. So here what will happen? The new node address will be saved. Okay. Here what will happen? The new node address is saved. The next new node tends to previous is equal to PTR. So this is a new node, and previous part what will happen? This PTR node address will be saved in a new node previous. So this is the new node. Okay, new node previous is this. So in this part the PTR node. So this is the PTR node. This node address is saved here. Okay, then new node tends to next is equal to null. So this is a new node tends to next. So here it is a null because it is the last node. Okay, so this is the procedure. So first what we are doing, we are checking this condition. Okay, we are checking this condition. This condition is true means we have to execute this statement. So once this condition becomes false, that is we find the last node. Then what we have to do, first we have to PTR tends to next. So this is a PTR node, and it here next it should be we have to store the address of this new node. Then new node next, right? Sorry, new node previous. So this is the new node previous. Here we have to save the address of this PTR node. Okay, then in the new node next, here we have to store the null. Okay, so this is the procedure of inserting the new node at the end, and this is the code and algorithm. Okay, so code and algorithm. So here first we are checking overflow condition, then we are creating the new node and we are allocating the memory space. Okay, then after that here also same only, new node tends to data is equal to VAL. Okay, so here see we are allocating the data, then we are assigning PTR is equal to start. Okay, then we are checking the condition. So here we have to repeat the step 8 while PTR tends to next is not equal to null. Still that's getting false, the loop will be executed. So inside the loop there is a statement PTR is equal to PTR tends to next. So here PTR tends to next. Then what we have to do once this become false, next what we have to do, PTR tends to next is new node. PTR tends to next is new node. Then new node tends to previous is PTR. New node tends to previous is PTR. Then new node tends to next is null. Okay. So this is about inserting the new node at the end of the doubly linked list.